Talking, but you are muted.
Sorry, man, I did not know. Sorry, I kind of like just figured it out. Okay, so guys, I apologize for leaving the last class right. Something urgent came up, so that's the reason. But anyways, yeah, for this, I think I dropped an assignment before I left, in which I said write a follow that goes through the list of the names we were talking about in the last class, right? A follow that loops and then print each names. So to begin this class, right? I don't think I won't give an assignment. I won't check. Just drop it in my mail. I'll drop it now. I don't know which mail should I give you. All right, this one should go. All right, gmail.com. Okay. Yeah. So everyone can drop the assignment there. I'll check that out maybe later. Um, back to the order of the day. So I think we actually have done a lot, though not really a lot, but to an extent we've gotten to list, which is kind of like the main part of that, and yeah, basic that actually. So I believe we are moving into control structures, right? I before I zoned out. So yeah, I'll just go ahead and clear the last class tutorial from the screen. So let me just do that. Let me zoom in. So yeah, it should be fine. Um, it's not that. Oh, everything. So okay. So yeah, void main as usual. And let's get started with the order of today. So today we are going to be looking into something called control structures. So I believe most of you attempted the tutorial, right, or the assignment I gave you guys. So I don't know if by any chance you came across something you did not understand, maybe while trying to like solve the assignment, and maybe you want to ask. You can do that now before we jump into control structures. And yeah, does anyone have any question? Okay. I don't know if you feel you cannot talk right, feel free to drop it in the chat. I'll check it once I get a notification. Anyways, back to the class. Let's talk about control structures. So control structures is kind of like is as simple as decision making. So, take for instance now, you want to build a traffic light. I don't know if you've heard this example before, but I know that I heard it somewhere at some point when I was starting. But yeah, if you want to build a traffic light, right? For instance, red is to stop, red is to stop, red is to stop. Maybe green is to go. Yeah. Okay, yellow is to prepare yourself or something like that. I don't know what the word is. Prepare yourself already. Yeah, ready is the word. And then green is to go. I know you've looked at what's the name? You've looked at traffic light and probably you've wondered how do this thing work? How do they function? How does the light know that it's time for it to like move to the next color and the next color and the next color? Yeah, we are going to try to recreate a scenario like that. In that, using that, right, we're going to try to play around creating a traffic light using control structures. So control structures is just a way to make decision using using whatever language you have on ground, right? So control structures. So let's take for instance now, based on a condition, if you want a particular action to happen, you can easily like perform the action and like that, like that, like that, like that, like that. But yeah, let's try to build our traffic light and let's see how it goes. So there are different control structures, right? If you noticed in the last class, I made mention of these control structures. Let me. Yeah. I made mention of if and else, for loops, and switch. Right. There are other control structures like while and yeah, I think yeah while and is there anyone again? Anyways, if I remember that, I'm going to add that. But anyways, there are still other control structures, right? But yeah, these are just the basic ones you might want to like pay attention to. So the first thing right is if else. So it's if else is basically like checking if a particular action is true. There was a data type I mentioned earlier, which is called Boolean, the Boolean data type, right? So Boolean data type, and if you want to define it, it's bool, basically bool. So if the Boolean data type, if the Boolean is true, or if whatever action you're trying to like check for is true, you can perform an action. Else, you can perform another action, and like that. Let's even try to play around a little calculation. So let's say we have a sum of a and b. We have a number called a, and maybe this is 30. We have another number called b, and this is maybe 90.1. I don't know how this came about over here. And then if you can easily check if the addition of these two values, if they are greater than 1000, you can print greater than 1000. If they are not greater than 1000, you can print it's not greater than 1000, blah blah blah, like that. So let's try to let's try to check for this scenario. So if a plus b, let's create another variable called sum equals to a plus b. So the total sum is, let's print here, the total sum is sum. So I believe you should remember the concatenation, the string we did, and what print statement actually does. So print the total sum is this. This is just a way for us to like know the sum before we even check for the condition. So if sum is greater than maybe 1000, I really don't know what a plus b is. Okay, if sum is greater than 150, let's use a closer number, and I'm not just exaggerating, but print sum is greater than 150, is greater than sum of A and B is greater than 150, right? Else print let's copy this. Print sum of A and B is not greater than 150. Print sum of A and B is not greater than 150. 150. And yeah, so when we try to run this, if you use your calculator, I think this should be around 120.1. So that's the sum. It should be 120.1, and definitely 120.1 is not nowhere greater than 150, right? So it's going to skip over this condition and up onto the next condition. So let's try to run this. So sum of 30 and 90.1 is not greater than 150. So as you can see, yeah, because it's 120.1, right? It's never greater than 150. If it's the other way around, right? Yeah, is less than, is not less than. And when we try to run this, sum of 30 and 90.1 is less than 150, because obviously, right, it's less than 150. And also there's another check. Another check you can always make, which is also this equals to. So let's say you want to check if two values are equals to each other. You can always do this and you are fine. So once you do, if sum equals to 150, definitely it's false. So sum of sum of A and B is equals to 150, and then the sum of A and B is not equals to 150, right? So that's when we try to check this, definitely is not equals to 150. But if we check it against 120.1 and we try to run this, right? Yeah, definitely it's equals to, because the value is 120.1. If you okay, fine, let's uh let's approximate, right? If you try to approximate, definitely we already changed the whole thing, and it's never going to be equals to. So when you try to run this, it's going to print is not equals to. So that's kind of like the basic of a base control structure, and I feel you can already like figure out how control structures work. That's the if and else statement. If and else statement. Though, yeah, we are still going to like go into a bit more advanced if else statement, right? But I just want you guys to like get an idea of what this is. And please, so I don't go faster than myself. If for any reason I start rapping, and maybe when I say I start rapping, that means you don't understand what I'm saying, right? Feel free to stop me either by chat, just drop a chat once I get a notification. Once I get a notification, I should attend to it. And yeah, you can also try to like unmute your mic and call my attention to something I am already like going off on. So yeah, that's for that. Um, if you don't understand anything, please feel free to like drop a chat and feel free to call my attention so that we can just flow together. But yeah, this is just what how a basic if and else statement works. So if and else statement is for us to like make decision. It's for us to make decision about something. So we, let's say, want to compare two values together. I want to compare. We want to do something. So we want to check if something is inside something. Any value that returns a bool, any value that anything that returns a bool, right? Can be used to like decide an action in which we just did here. So if for any reason, let's try to do this right. Let's try to play around some operators you can use. So let's say you want to compare if the sum is equals to 20. Let's try to print this out, and let's even comment this. Maybe this is me jumping, but yeah, let's comment this and try to print sum equals to 120. Let's start with this, and then let's check for another thing. Print sum is greater than 120, and print sum is less than 120, and then print sum is greater than or equals to 120. Print sum is less than or equals to 120. What helps again? Okay, so these are still basic comparison. Another thing you can check for is print sum is string. Let's try to run our all these rush we've been writing since, right? So basically, this anything here should return either true or false. Anything here, anything we put in here should return either true or false. So let's do a bit of concatenation so that I can so that we can always tell which is which and which is not. So let's concatenate. So when we do this, uh, this and not this way. Sorry, this, this. Yes. this concatenation, and then the next one is this. Okay. Okay. And then the next one is this. Um, yeah. The next one is this. And finally, the next one is this. Okay, so let's try to run this. And when we run this, you can see that everything basically returns for either false or true. So whatever you are putting inside this condition has to result in either false or true, whether you like it or not. So you cannot just come here and put if sum. You cannot just say if sum, right? If sum, you should get an error. So it must either it's either you are checking if true or if false, right? You must be checking either of those. That's the only time you can execute a condition. But yeah, that's just what I wanted to call your attention to. And another thing I did not like mention is this is what this is does. This is kind of like checks the data type for you. So if you try to like check if some is a string, definitely it's not a string because it's a number, right? And that's the reason why we're getting this. So if you check if it's number, hopefully a true is true. So if you check if it's number, I don't know why it's trained on error. Okay, unnecessary type check. So this is always true, by the way. So when you run this, it's going to return a true. So sum is a string. So is always used to like check for a particular data type, and that's it. So let's say instead of sum, we have dynamic here. Instead of sum, we have dynamic here. You can easily just check the data type and then you run this, and then you are going to verify if it's a number or not, or you can check if it's a string, and then yeah, just run and you get false. So basically, right, that's just it. Control structures kind of like is makes decision based on boolean values and boolean values only. That is just it. That's the if else statement control structure. So okay, so let's try to build our traffic light. But before we build our traffic light, there was something important we actually skipped, which is functions, right? So what exactly are functions? What exactly are methods if you're coming from Java? Yeah, what exactly are methods? What exactly are function? So a function is a piece of code that kind of like performs just one action. Let me put it that way. So yeah, you can have a function that has over like 500 lines of code, right? Yeah, yeah, you can have a function that has over 500 lines of code, right? But still exec, but just performs just one action. That's why it's called a function. So yeah, maybe you have a function that does different things. I don't know. You are probably getting the idea wrong, but yeah, a function is meant to execute or perform just one action. So let's say we want to print something. What can we print? We want to print whatever value is being passed into our function. In order to create a function, there are two things that makes up a function. The first thing is or three rather, the data type, the name of the function, which is print value, the name of the function, and then yeah, the data type, which is also the return type. Let me try to like decorate this. Void. Void here is the data type and return type of our function. of our function. And then the print value is the name of our function, a of our function. Yeah. Also, there is a parameter going to come into our function, right, in which is going to be dynamic value because we want to be able to print anything. We want to be able to print anything. Print value is the name of our function. Then value is a parameter, is a parameter or argument and being passed into our function. Our function. What else again? Okay, so this is the body of the function. This is the body of the function. So for you to just be able to maybe relate or whenever you come back to this video or with this, let me remove this bracket and do something better and cleaner. So once you do this, so I'm going to dissect everything happening here in a bit. Right, I'm going to dissect everything happening here. So there's a void, there's a print value, there's a value, there is this. So let's take this to the bottom a bit so we are not confusing ourselves. So yeah, what we want our print value to do is for us to be able to print whatever value is passed inside here. So let's try to print value. Print value. Okay, so when we try to print value, instead of us using this our print statement here, let's comment everything we have here. I mean, this is getting rough already. I'm trying to look at a way we can do this. Okay, I hope if it's confusing, right, I can just take this to another file and maybe start all over again in this place. But yeah, if you guys can still flow with it, then it's fine because I think we might still come back to these values. That's the reason why I'm not deleting them. Okay, so yeah, let's try to print some. So you can see we created a value here. So a function here rather. So print value and then sum.
Sorry, Caesar, there's a question.
Oh, okay. All right. Yep. You can go on, Elizabeth.
Hello, sorry, can you hear me now?
Yeah, I can hear you.
Yes, it's from the print stuff, the sum, the one you did earlier on. In the
Okay.
fifth print, like the one you said, print is equals to sum less than or equals to 120.
Okay.
So when you put your sum, you did greater than or equals to 120 again. Is that a
Oh,
mistake?
yeah, that's
Yes.
a mistake. That's a mistake.
So I want
Yeah.
to better.
Yeah, so that was a mistake. Yeah, sum is less than equals to 120. Sum is less than equals to 120. Yeah. So you guys can correct it and just in case you're following. This was a mistake. All right, thanks for that. Okay, let's comment this out. So we have a print value. What we want this particular function to do is to print whatever value we pass inside. So let's say we are printing Caesar. Let's say we're printing Caesar. Let's say we're printing LadiesInFlutter. Hey, seriously, I'm already using just the print statement. Yeah, let's say we're printing LadiesInFlutter. Right. In Flutter. When you try to run this, it should do the same thing your print statement should do. But as you can see, right, we kind of like separated these to a separate chunk of code. So we it's just more or less like a way to keep your code clean. If you realize, right, the first this particular action we did, what we are just trying to do is like we're trying to print some things, we're trying to play around control structures and the likes like that. But as you can see, it's already messing up our void main function. This is a function. As you can see, it has the same structure of a function. It has a return type or a data type of void. That means void basically means it's not returning anything. So it's just more or less like zero, null or void. Yeah, it's not returning anything. The main is the name of the function, and this and this is the body of the function. So whatever we pass into this body is what that looked at to run, and yeah, whenever we call a function, right, we can easily just you can easily just call it value name, and you should be good to go. So that's just basically. Let's try to run this. Let's try to run this. So when we try to run this, we should have 120, which is the first sum, Caesar and LadiesInFlutter, because that's what we made our function to do. And as you can see, right, we can actually use this function as many times as possible. So it's not like I wrote print value here and then I have to come and define another print value on that. Ah, the data type is a number, right? What it does is it adds whatever value you pass into it. So add the first one is probably a number. I'm sorry I use number a lot, right? I can use an integer, but I just feel like I like to stay generic when it comes to numbers, right? Yeah. So anyways, num had number A and number B. So there is going to be a different scenario with this. As you can see, even though we have related scenario with our initial function, our initial void print value function, right? Even though we have related scenario where we have the data type, we have the name, we have the parameters or arguments, right? And then we have the body. We are still getting an error, and yeah, that's because there is no return value. So yeah, the reason why we don't have an error yet is because the value here is void, and like I mentioned, right, is empty. So there is no need to even return in the first place. But you can always return, right? If you want to return, you just do this and you're fine because there is nothing to return. So if you do this, you are fine. If you don't do this, you're fine, right? Because it's a void scenario. But for this, you have to return a value. So yeah, you have to return a value and it has to be the same type, it's the same data type, right? So let's try to like explore this. So in order to return, we do this return and then followed by the return value. So if you try to do the same thing we did in the first place, right? Same thing we did the first time, we are going to still have an error because yeah, we have to return a value whether we like it or not. So we cannot just come and put return, do the return the same way we did for the void, right? We have to return a value, and the value can't be a boolean. You can't return false. You can't return a string. It has to be the same value that you're passing in, that you titled your data type. So yeah, what we want to do is we want to add whatever parameter, a and b parameter is being passed into this function. So return a plus b, and as you can see, we stopped having our error. So yeah, this particular aspect of programming generally, it's kind of like it's a tricky aspect, right? And most times I notice it takes a bit of time for people to get it. But that's why I'm telling you to just ask your question whenever you feel it's right, you feel like you're not getting anything I'm saying anymore, so that I can actually zoom back, try to relate it with a real world scenario, and then and then give you like a very very good answer, hopefully, something that would help you understand. So a function is something that allows you to perform an action, right? So and you have to return a value, except the scenario is void. You have to return a value. So in this situation, right, what we want this function to do is we want it to add this value. Let's create another function and call it multiply. Add multiply. Multiply. And then we have a num a and num b. So what with same thing we did earlier, return um, a multiplied by b. Let's have another function that does division. Num divide num a and num b, right? And yeah, return a divided by b. So let's try to do this, right? So we are trying as much as possible not to have a decimal in place, and not necessarily a decimal, but not to have an improper fraction, right? That means we don't want a scenario where b is bigger than a, and then we are kind of like
Caesar,
well,
I
can
think
you
there's a
ask your question?
question. Okay.
Okay, good evening. Sorry, I joined late. I'm a bit late, but I'm getting confused based on this norm. Did you define this norm before, or is norm a, because this norm here, before you now define the function,
Yeah.
so and add the parameter, I don't understand why that norm is there.
Okay, so num is the return type of whatever is happening inside your function. So let's say your function is something that performs an action. So let me try to look for a scenario. Num is basically a data type, right? It's a data type. I believe in the last class, oh yeah, I believe in the last class, right? We discussed not is it last class or the upper one? In the last class we discussed about data types in that, and I mentioned integer, I mentioned num, in which we performed some action. I mentioned double, I mentioned string, and blah blah blah, like that. And yeah, num is basically a data type. So you cannot just manufacture a name from your head and say, hey, okay, Messi. Hey, Messi, you are my return type. No, it's definitely not going to work right. You have to use a proper data type or a functional class. I don't want to I don't want to go into class now, right? I want that to be like kind of like in the later of our tutorial and likes like that. But yeah, you can just manufacture a name. It has to be a data type. So meaning you can create a function that returns a list, and let's use another function. So let's create a function that returns a list. We can give it a name called return list, and yeah, as usual, return a list. We can create another function and title it string return string, right? And then yeah, return a string, and you should be fine. Yeah, return a
Okay, okay. I think sorry, because I'm the one that missed the whole thing. I didn't. I just this is my first time of joining. Okay, I don't know that norm is a return. Is a sorry is a
data type,
this thing.
right?
Yeah, is a data type. So what
Okay.
type of data this norm collects, as in like this list, list in other language you return a list of these things. So and int return a number and rest of them. What type of data type do this norm return, as in collects,
So
please?
yeah, I get your question right.
And
So
secondly, please, I would like to have the recording for the past class so that I will not be asking some small questions. Thank you.
oh yeah, Grace will provide that.
Yeah, Cherem, I would do that. I thought I mailed that, but I would send it to the group as well.
Okay, all right. So none is a generic data type for anything number. So I know you're familiar with maybe I don't know what language you're coming from, right? I know you're familiar with float, you're familiar with double, you're familiar with integer, right? And maybe number just kind of like floats out of it. But number is a data type that can take in any form of number. So whether you have decimal number, whether you have a float, a long integer or double, depending on the scenario, right? Yeah, a number is a data type that accommodates that. So you can create a number variable. Let me even try to like explain that to you. So yeah, you can create a number variable that takes the decimal, as you can see here. You can create a number variable that takes just an integer, as you can see here. And what form of number again exists? So, anyways, basically we have decimal.
Okay. Both the double and large int, all those things can be
Yeah,
in
yeah,
this,
exactly.
right? Okay. Thank you.
Yeah, exactly. So yeah, that's just the way number works. Okay, so basically you can return a list back to this, right? You can return a list, you can return a string, you can return any value. You can return a boolean as far as you're returning a boolean, boolean, right? Because you're going to be using functions a lot. That's the reason why we just have to deal with this. So return a boolean, which is false. A what the hell am I typing? All right. So you can return a boolean, return anything data type. Okay, let me just give you kind of like a quick spoiler. You can actually return your own type, your own customly defined data type. Let's say I have a class. Well, we are not going to discuss class now. I just want to give you a spoiler, right? Let's say I have a class. I can name my class Caesar, and yeah, I can name my class Caesar and create a function that returns Caesar, and we should be fine, right? Return Caesar, and as far as I return Caesar, we shouldn't have any problem, right? Okay, so Caesar returns Caesar and be fine. Well, please just ignore whatever I did here, and we can flow with the class. So back to our addition, division, multiplication, and subtraction, right? Let me create another number function that subtracts. So subtract num and num b. Well, now I can remember. So return a minus b. Okay, instead of me to even jump, let's try to like have fun with what we did here, right? Okay, so you know what? I believe you guys still have access to the video. I don't like the way this whole screen is messy, but you know what? Okay, let's do this. Um, New file. This should be kind of playground. Contains all the essay value and definition. Void mean. Okay, so I will just move all this. I'll move this function here, so that we can have a cleaner ground to perform whatever I want to perform. So yeah, there's a playground of that file that accommodates whatever we are doing. So as you can see, we have a function that adds the number. We have a function that multiplies a number. We have a function that divides a number. Right? We have a function that does whatever. So I want to show you guys something interesting. So the first thing, right, is let's do this. Okay, a number A equals to 45, and number B equals to 90, and yep, okay, that's it. Number A equals to 45, number B equals to 90. We want to add A instead of us doing this that blah 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 like that. We can just easily call our add function, right? We can call our add function and then pass in A and B. But basically, this will do nothing because we are not assigning this to a value. So one thing we can do is we can just have a final added value equals to add A and B. So yeah, I knew I was not supposed to use final yet. I don't know if I explained final, but final is a way to declare a variable so that you can't assign it anymore after you've declared it final. So take for instance now you have this number A. On a normal ground, right, you can come here and say A equals to 90 because you are not happy with the value. But if for any reason you declare A final, if for any reason you declare A final, you can't assign it anymore. So let's go ahead and let's declare our number B final. So num final this, and it should be fine. You might not need to add a data type, but for readability, right, I suggest you add a data type. So yeah, that's it, right? So we have a final num added value, and we are setting it to this function. Let's create another variable, final num multiplied value, right? Multiplied value equals to multiply, and yeah, we pass in our A and B value, and we have final num divided value equals to divide A and B, and then we have final num. What's the last one? Subtracted value equals to subtract A and B, and yeah. So one thing we would always want to do is we want to print our value, right? We want to print it on the console so that we can see what we have done and what we've been doing. So let's try to print out this value. So print added value and our basic concatenation added value. Okay, print multiplied value. Yeah, yeah, multiplied value, and then multiplied value. And we can just duplicate this divided value and then divided value. And divided value. And another thing is, what's the final one? Why am I coming to right brain? Oh, subtracted value, and subtracted value. Okay, so let's run this. Okay, so as you can see, right, the added value is definitely 135. If you use your calculator, you should find that out. 90 plus 45 is 135. The multiplied value is 4050. 90 plus multiplied by 45 is this. The divided value is 0.5, and then the subtracted value is 45. Is minus 45 rather. So one thing I was trying to do, I wanted to do initially before I decided that okay fine, let's just even see what we're doing this morning. I wanted us to kind of like look for a way for us not to like get a decimal or an improper fraction to the extent where we are getting 0.5. Right. is basically 1/2, right? Because yeah, when you let's say we have 45, and I don't know, I don't think I'm supposed to be doing mathematics here, sha. But yeah, let's say we have 45 and we have 90, and we try to do and we try to kind of like take this to the smallest end. We have this because when you divide 45 by this, we have one, and then we have two. That's 90 divided by 45. We have two for it, and that's how we came about 0.5. So let's say we don't want to have this fraction, or we don't want to have an improper fraction. At least, even if we have an improper, yeah, a fraction, right? It should be a proper fraction. What I mean by proper fraction is when the denominator is greater than the numerator, right? The numerator is the top one, the denominator that's the bottom. I don't know. I can't remember all those shit. But yeah, I believe you know what I'm talking about, right? But yeah, the top and the bottom one. So we want as much as possible the top one to be bigger rather. That's the numerator. Is it numerator? Anyways. Yeah, we want the top one to be bigger and we want the bottom one to be smaller. Yeah, I don't believe I'm doing a bit of maths. Please, you don't need maths to program. This is just me trying to like explain the whole rubbish going on there. So one thing we can just do is I'm trying to like get into a way where I can chip in control structures without stress. So one thing we can do is we okay, Motoraya.
Hello, good evening. Please, I have a question, or I want a clarity rather. So,
Okay.
when you at this top part, when you did when you initialized, when you created a variable called it divided value, subtracted value, then you now like initialize it within the function you created. So my question is that for this operation, or for this variable of that's num a num b that you initialized already, if you want to
Yeah.
like perform the operation, it's not possible to just like write a print statement and just pass in the function name inside the print statement. Won't it work that way?
Okay, so
That's why.
you mean this
Yeah,
print
I mean that. Yes, yes, yes.
added
No,
value.
the function name. That's like
Yeah.
the num add num, like the function name below.
Oh yeah, yeah.
That's
Let me
add,
see.
multiply, divide.
Okay, so this
Yes.
is what you meant, right? Like had printing this right.
No, like without the what's it called? Is it the quotation, or I don't know? Like you just
Oh
pass
yeah,
in
yeah, yeah. It's
add.
definitely going to work, right? For me,
Okay, okay,
I just feel like I'm printing this thing. So
okay,
if you
okay,
print this, if you print this also, you're going to get the value. So
okay,
let's
okay.
check our comments. So as
Thank
you can
you.
see, 135, right? Yeah. So that's
Thank you.
okay. So that's regarding that. So this basically a function is a value on its own. Uh, that's what except it's void, right? It's a value on its own. It can either be a number, it can be maybe a list, it can be something, but it has to return something as you can see here, right? So yeah, you can always print it separately. So let's go back to the first scenario. Okay, so okay, where were we? Okay, yeah, the situation where we have right is where we're trying to like find a way to make our bottom fraction, the bottom value, um smaller, yeah, smaller than the top one. So we want the top one to be bigger so that we don't have improper fraction. Yeah, I know I can still remember that. So that we don't have improper fraction, right? So basically that's what we're trying to do. And the only place we have improper fraction is let's try to run this again. Okay, improper values definitely. The only place where we have improper fraction is this. Another place where we have improper value is this minus 45, right? Because of the fact that we are trying to subtract a smaller number, a smaller number from a bigger number, or a bigger number from a smaller number. Anyways, 45 comes from minus 90, blah blah blah. Like that. So what we want to do is we want to check and make sure we are getting a proper value. So if we're even getting a decimal, it shouldn't be an improper fraction or improper decimal, right? If you're getting this, we should have a positive value and not a negative value. Even if it's positive zero, though there is nothing like that, but even if it's zero, right, we should be good. Anyways, In order to do this right, what we have to just do is we just have to do a check if B is greater than A. If B is greater than A, then we definitely want to return B minus K instead of A minus B. You can either leave it like this, right? So basically, return statement, whenever you call return, it doesn't call any function on that automatically. So whenever you call return inside an if statement, if if this is true, if this particular scenario is true, it's never jumping down to this. So you can either leave it like this, or you can be fine with putting else there, and you are still going to get the same result, right? So you can put else, and you have this. So when we try to run our subtraction, hopefully we have just 45. So yeah, this is another useful scenario where a control flow would work fine, which is our if and else statement. This is a very, very useful scenario. Another scenario is our division, right? You know, we were trying to like get rid of this zero point 0.5. We want a proper fraction at least. In order to do that, right, same check, right? If if B is greater than A, we want to do turn B divided by A. Divided by A. Okay, yeah, let's experiment this. This time we are not adding else statement, right? And when we try to run this, we should have 2.0, basically. Yeah, I know. Yeah, I know. You can ask a question. Or was it a mistake? Okay, once she's ready, she can always like come back. So as you can see, right, we've been able to like use our if and else statement to like check and then make our values proper. So you can see we have 2.0, we have 2.0, we have 45. One interesting thing we can do is okay, we don't want to return 2.0, right? I think we talked about something in the last class. Let's try to use seal and let's see. Is it divided value? Yeah, divided value. So we can use dot seal. So if you check this dot seal, if you hover over this dot seal, right, it returns the least integer not smaller than 2.0. So what we want to do is we are converting it to an integer instead of a double. As you can see here, even though it's claiming number whatever, it's still a double, and we don't want a double in our values, right? So you can just play around this. There are a lot of functions you can use. Dot seal would just basically like round it up for you and then give you just 2. So as you can see, we have 2 here. If you want to play around other functions also, okay, I don't know how this is working, but yeah, if you want to play around other functions also, right, there is absolute. It's absolute, right? So for that instance where we had negative number, if you use an absolute, it's just going to return the positive value without returning the negative. Let's even explore that. So there are just a lot of functions you can explore with this. Let's explore that. So let's try to remove our if else. I think that was for this. Let's try to remove our if else for now and let's run this. If you run this, you see we have minus 45. And then when you come here and you put dot absolute, which is dot abs, and you try to run, you get just 45. So that's it. You don't have to cram this, right? If you just come here and I don't know how it is on Windows, but yeah, if you hold maybe control, it is control or command or there is no command on Windows. But anyways, you can try to like figure it out. If you hold control and space bar, uh, you can if you hold control and space bar, you should be fine. You should have all these functions. So as you can see, absolute, clamp, remainder, seal to double, compare, blah blah blah. You can just read all this and see what they do. So there are just a lot of them to help you play around. And yeah, that's for that. So let me uncomment what we commented in our if else, and we're back. So let's try to run this. Yeah, so we have O number and we can seal our division. Let's see. When you run this divided value, blah blah blah, what else again? Yeah, so let's talk about our what again? Let's talk about our traffic light. Does anyone have any question before I proceed? Does anyone have any question? I might be rapping. I know that I might be a very fast speaker sometimes, and also I might be a slow speaker depending on the scenario, right? But I believe to an extent, maybe sometimes I'm very clear, sometimes I'm not. Just in case that happens, right? Please feel free to draw me back, like I mentioned. Wait, give me a minute. Yeah, feel free to draw it back and ask your question. So everyone is flowing, everyone is vibing, everyone is on point, and then we are not moving faster than each other. That's one thing, right? So we are hardly here to learn. And I also mentioned, I think I mentioned that in the last class. As much as I'm coming here to like touch on points, right? Please, in your own layer, that's why I give assignments at the end of the classes in your own layer, right? And please don't forget to drop my assignments. This is the email. I'll drop it again. Or at your own layer. Please do well to play around all those things we're talking about, right? So when you start building like pre-world applications, because definitely we are not building you are not learning that to come and be building maybe building green lights, red lights, yellow light, or what do they call that? You are not learning that. You're learning that to build real world applications. You have to be able to make decisions using real world scenarios. And the thing is, most of the things you're learning in this basic class, right, is going to be very, very useful. I am trying as much as possible to see if there is a way we can extend this class, right? So the plan was just 4 weeks, but looking at it, right, 4 weeks might not be exactly feasible because of the we might checking into Flutter and maybe building a calculator with what we learn, whatever we learned in our classes, right? So everything we've been doing here, all this addition, subtraction, it's going to be very, very useless if we cannot apply them to the real world. And I feel you have to understand the basics for me to be able to even like talk about the usage because yeah, definitely right. We are not yet in Flutter. I just want to like introduce you to Flutter with that with creating a calculator application, right? And yeah, basically. And also, I think I have a calculator, so I might get up in a minute. Just in case you care to like check the code. Okay, you get to check the code. The calculator should be somewhere. See here. It's not my pinned whatever. Okay, so let's check the repository. So I now have a calculator. Flutter. Yeah, this is it. So I built a calculator application, and this is the calculator application with basically some of the things you learned here. If you want to explore, you can play around it. Um, that's the repository. Well, yeah, I'm just trying to like tell you, okay, fine. Maybe I might need an extra month where we can explore this whole code base together, and we can look at how to do this and how not to do that. But yeah, back to the class. So
Sorry,
we want to
Sugar.
build.
If you're up for
Okay.
it, we are up for it. You get.
Oh, okay. The extra week, right?
Yes, sure.
Oh, all right, fine. Okay, then let's get into this whole green light, red light, yellow light thing. So we have a void main. We have a void main as usual. I don't know, yeah, and which is our entry point. So we have red, yellow, green, black. What we are trying to do is we want to I'm trying to look at this. Let's try to do this. I'm trying to look at a way to automate our green light, right? On a normal ground, what I can just come is I can tell you to I can just come here and I can create a function. Basically what it does is make decide what light to show or something, decide light, and yeah, decide light. I'm trying to look at the best way we can play around this so that it's still as fluent as possible, and I'm not just kind of like hard coding value. I want to kind of like pop out of hard coding, because definitely I can just come here, find a variable, final green light equals to green light, final red lights equals to red light, then final yellow light equals to yellow light. Right. So what I was trying to do is, well, looking at it right now that I've looked at it, I can see that there is no way I am going to implement this without us diving. We are going to enter something called future in that. We're going to enter something called future in that, and then something called strings, in which I am trying as much as possible to avoid. I can still like spare future, but I'm trying as much as possible to avoid streams for these beginner parts. So yeah, maybe we are just going to do it the native way, right? We are just going to do it the native way. Um, so we can define a boolean value, right? We can define a boolean value. Let's take this to our function and let's show this. So it's returning a string. So what we can do here is we can pass in a boolean value, should go, which takes in should go, right? And what we can do is, if should go, return green lights, and then else, return return red light. All right, return the red light. So when we come here and then we try to print our decide light or traffic light, right? If we try to do this, traffic lights, and then we pass through here, we should have should go printed. Should go printed, and we should have green light. And we pass in false, just like we've been making in our decisions, right? If you pass in false, we have red light. That means you shouldn't go. Another value we might want to add is ready. So we can pass in another value doing this is, I want to like draw your attention to something. So if you notice, right, we've been just passing values, right, and for some you can just come here and then you can, instead of, maybe let's say you want to give should go true, and then you want to give ready false. By mistake, what am I doing? Let's say you want to give should go true, and you want to give this false, right? By mistake, you can make the mistake of substituting both. That means you are doing this. What the hell is happening with this keyboard? Yeah, that means doing this and doing this, right? You can make the mistake of doing that. That's where something called named argument comes in. So there are situations or scenarios where you can have like over 1,000 arguments. There is no limit to how many arguments you can have, right? So the only thing is they cannot have the same name, and that's the reason why we are getting errors. But anyways, yeah, there's no limit to the amount of argument, and definitely you cannot start tracking everything and be putting false to false. It's going to like decrease readability. So there is something called named arguments in which we are going to be using. So while this unnamed argument depends on order, that means the order of the way you pass in the argument, right? Named argument doesn't, right? So let's do this. Let's do this. Named argument doesn't. So let's do this. So in order to create a named argument, what you can do is just so this is another thing, right? This is another interesting part of that called nullability. So nullability is basically a way to it's just kind of like making your data type have a decision of either being null or maybe having a value. So we have this. We can have a norm A and we can have this, right? So for some reason, this value is empty. It has not been initialized or something. There is no value there. We can give our IDE or our code editor the decision to either decide if this value should be null in case there is no value being set, or it should have the value. So nullability is just kind of like empty. It's as simple as that. So um, void null, void and null, they're kind of like in the same category. So basically, they are nothing. That's just it, right? So meaning when you make this value nullable, it means you can actually like pass in nothing, and you should be fine. But if for any reason you don't make this nullable and you try to run this code, and there are a lot of errors, and you try to run this code, let me comment this, and you try to run this code and you print A, and you print A, right? Okay, so as you can see, it's not even going to allow us to run the code in the first place. So when you try to print A, the non-nullable local variable A must be assigned before it can be used. Because it's non-nullable, right? You cannot print it. But if you had your question mark, all of a sudden our error is gone. And when you try to run this, right, you should have null printed in our what's the name? In our console. So null is a data type of its own, right? I like to tell people, though you can feel free to argue, but this is the best way to understand it. So null is a data type of its own, right? And then null is just kind of like it's giving you a decision to either choose maybe this data type or nothing, right? And which is null. Anyways, that's just kind of like the base thing. So as you can see, this is a null data type, and yeah, if you try to print this, and you run this, you have your null. So this is how to define null, or it's just basically how can I put this? Instead of instead of just a number, right? You're saying either number or null or null data type. So as you can see, I define a null data type here, right? So basically, that's what you're telling your ID or your whatever to do. So either null or whatever data type. You can also do the same for string, right? String, any data type you can think of. I think we defined a data type called Caesar, except I deleted it. You can also do that for Caesar if Caesar ever exists anywhere. So you can. It's just a way to tell that this value can be nullable. That means it can be empty or not. So basically that's just it. You are going to see the use case in the future, sure, but I just feel like I have to wrap up briefly about that. And this is kind of like something a lot of people find confusing whenever they are working with that. Right. This is something a lot of people find confusing, and yeah. Anyways, if you have a question, please feel free to ask the question now, so
Um,
that we can just talk about it. Yeah.
okay, I have a question, yeah. So since you're talking about this null type, do you care to talk about the explain the other type? You know the other null type.
Um, I'm sorry I missed that.
Okay, I said since you're talking about null type here, do you care to explain the other null type?
The other null type.
Yeah,
Okay. So
like when to use both, to use either of it.
or when to use either of it. So when you are using this, so basically, right, this is the most useless data type ever. I'm for real. So null is the most useless data type. I know some people can argue with me that maybe it's what's the name? Maybe it's var, or maybe it's var, or maybe it's dynamic, depending on whatever you use, right? But null is basically kind of like there so as to just represent. But basically, right, if you are sure that your data has to be null, that means you're not assigning it to any data. So you're not doing this. You're not doing this, right? If you are sure your value has to be null, you can just define the null value here, and you're good to go. But basically, right, there is no too much use case as to when to use this particular null data type, right? But basically, I think it's just a representation of the question mark we had in front of our other data type, right? So for instance, you have a string. For instance, you have a string, right? This is just kind of like making your string nullable. That means it can either take in a null data type. That means you can either set it to B. So let's say we have a string called str, and we want to set it to a value. You can set it to B, and you should be good to go because B is by default null. But you cannot come and set B to anything. You cannot come and set B to anything aside null. So that means if you define B, you cannot perform any data manipulation. You cannot do anything. The only thing you can do with B, right? That's why I mentioned it's the most useless data type is you can only check if B is equals to null, which is always true, right? Which is always true. B is going to forever be null, whether you like it or not. So there is no data manipulation that can happen with B. Yeah. So that's just the reason why it's not really like used. But you can just get to know that it's also a data type, right? It's just there. It's just there for their sake, and it's just there to represent our question marks. So instead of you having maybe string of this, maybe this is how they could have done it. Instead of you having string of null, right, they decided to just make it as simple as question mark. That's just what I feel happened in this scenario. But yeah, you really might not come across having to use null as a data type throughout your whole life of programming. But yeah, you can always use the I want to use it for. I've tried to think of a scenario. It's not just useful. It's just there to take space. Basically, that's just what that null is all about. But this is the useful one. This is the useful one. Where you have question mark in front of a data type, or let's say you have num, and then you have this, and then you have high. Let's say you have a list. You can have this, and then you have lists, and you're fine. So you can either set this to null, or you can either set this to a list. So it takes both value, but it will never take a string. It will never take a boolean. It will never take an integer. Yeah, so that's just basically nullability. That's just a slight basic, right? And you are going to find how useful it is when we advance, right? Yeah, you're going to find out how useful nullability is. It's a very very useful scenario in that, and that's the reason why I just felt like I had to like touch this, right? But yeah, does anyone have any question? So null is a very, very tricky part. Maybe if you're coming from Kotlin, you might not have a problem. But yeah, null is a very, very tricky part of that. And I feel like some people used to find it hard to like grasp. Most people, some people have had discussion with. But yeah, it's great if you can actually grasp it just once. But make sure you just practice. If you practice on your own, you're going to like see things. You are going to see things you can do with nullability and likes like that. So it's just making a decision for you to like for you to have either a string value or a null value. That's just what nullability is. So let's drift back to our traffic light. So we were having error in our traffic light. That's why I had to like explain. So like I mentioned, like nullability in that basically means empty. And if you're going to be doing this, a named parameter, a named argument in that, right? So let's see what a named argument looks like. So if you do this, you should have ready. That means you can have ready and pass in ready value. You can have should go. and passing should go value, which can be false or which can be true. And this can be true, right? So no matter the order you are passing these values, right, you should be fine. But one thing you can notice is if for any reason you clear this won't give you any error because of the fact that it's not a compulsory value, right? There are two ways to fix this issue. One is either by making both values nullable. That means this is just telling our compiler that okay, this value can be null, this value can be empty. It's just you giving it a go ahead that okay, fine, this value can be empty. Or there's a keyword called required that you can use to force the value to be compulsory. So let's clear this and let's use required and let's see. Right. So let's use required. So as you can see, our traffic light gave an error. If you also come here and you use required, our traffic light is still going to give an error. So let's say we now pass our should go and we put false, right? Yeah, you can see our error is all gone. If we, for any reason, remove our ready, we have our error. But if we come here and we remove our required, our error is gone. We have a new error here in which we have to like promise our compiler that our ready has to be nullable, in which we just state, and yeah, we have no error. So that's just kind of like a basic use case, right? So what we want to do is we want to force our compiler to like make sure these values are not null. Does anyone have a question? Because we are going to be stopping at the like right question. Please do well to ask, right? Don't worry. You can ask the most stupid question. I don't know. I understand how it is to start with programming, right? To get started and the likes like that. There are just a lot of things to take in, but I believe if you are patient, not necessarily not patient to the extent where you are lazy, right? But if you're patient, right, that means you are learning incrementally, not trying to like force a lot of things into your head, which I'm trying not to do. You should be fine. You should just do it and just make sure you keep practicing. So now that I even mentioned calculator, you can just build it. Let's see, that's even what you guys are going to do as an assignment. So go to the background, build man, I now that I look at itself, I already like solved the issue. I'll think of another assignment. Let's just continue. So yeah, print traffic light. We are now passing ready and we are passing should go. So when we try to run this right, since should go is false, we should return red light. It should return red light. So you can see red light. And if for any reason you make should go true, and try to run this to return green light. If you move should go from bottom to top and try to run this, right? Still returning green light, whether you like same value every time, no matter the scenario. So yeah, that's just something called named argument. Okay, sure. I know we wanted to use this ready for something. Okay, yeah. So we wanted to like talk about something called else if. So else if is kind of like a scenario where we want to check, after checking for this if value, we want to check, for another condition again if this one fails. So if should go right, we want to return green light. If else if right, else is ready is true, we want to return yellow lights. Return yellow lights. And then the final else. Right. We can always have else at the end of each state. All this our if statement, or we don't have else. We can remove this and we are still fine, like I mentioned. We can remove this and we are still fine. So the thing is, whenever you call a return this thing, it's never going to jump to the next line. It just automatically returns. Right. So you don't have to bother about adding else. But if you want to like fulfill all righteousness, in which you should do, you can put your health, right? But sometimes, right, there are some analysis that would always remove the health for you. Yeah, but you should be fine for now. Don't worry about analysis and just let's run this. So if for any reason should go is false, right? If for any reason should go is false and ready is true, we should have yellow light. But if for any reason both are false, we should have red light. If for any reason should go is true, um, green light. Yeah. So that's just basically how a traffic light functions. Though what I wanted to do initially was a way to like after 30 seconds, right? It should by itself print green light. Maybe after 30 seconds it takes it back to yellow, and maybe after like 2 seconds it takes it back to red. But I have pictured it and I saw that we are going to need is it that we need recursion, right? Is it that we use maybe a recursive function, or we use a string? In which both I don't want us to like jump into it now. So that's the reason why we just built this our basic green light, red light scenario. But yeah, I believe I've been able to explain if and else to the core, how to use and what to do, what not to do, blah blah blah, like that, right? So yeah, I don't know, right? Grace, I don't know if I'm going to be available for the next class, right? I think Flutter Forward, right? I should be in Kenya for that, so I am not sure. What is even the date? What is Friday? Let me confirm. Maybe I'm even back up. So I don't know if I'm going to be
Can
available for the next
check
class,
on.
but once I am back in Nigeria, I will definitely reach out and maybe we can schedule the class for like maybe Sunday if everyone is available instead of Friday. But
Okay.
yeah, that's the whole thing. Does anyone have a question? All right. So maybe I did justice to my explanation, or maybe you guys don't understand. I don't want to talk. But please, who is this? Please do well to always ask question. No, just always ask me, right? And I don't know. Whenever you want to send me a message on maybe Twitter or something, prefix it with ladies in flutter, right? Just prefix it with ladies in flutter and then ask your question. Your chances I'll check it and I will respond. So, but yeah, basically it's not verifiable, definitely to an extent, right? Ladies in flutter kind of like maybe raises the affirmation that I'm going to respond to the chat. So definitely, right. If you have a question, please feel free to send me a DM on Twitter. If you have my Twitter, you can send me a DM on GitHub. Even though I would have just dropped my GitHub. I think she would provide it for you. That's Grace, right? She'll provide that for you. If you have any question, that and yeah. So I'm trying to think of the assignment to give you guys regarding this control structure. What can we do? 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 We talked about control structure and functions. So the assignment for today has to do with both. Okay, 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 okay. You know what? Let's just build in our own background, like let's just build what's the name? A traffic light. Same thing I did here. I'm not going to push this code to GitHub. So you can always come back to like check. Build your traffic lights. Your traffic lights. Traffic lights. And also just basically same thing we did in this class. Build a traffic light, your own version. So when I say your own version of traffic light, you can go and do research about some countries that maybe use like 5 lights, right? And what the light does, right? And then you can try to do it and try to implement that. So you doing the same thing I did doesn't mean you're not like learning or you're not doing anything tasking. It's just you repeating it and then maybe you're getting familiar with the whole code base and how it works. So try to manipulate everything I did here and just play around it. Build your own version of traffic light. And let me check my email. Yeah, build your own version of traffic light. And what else again? Okay, build a function. build different functions that perform different arithmetic operations. Operations like we did earlier, like addition. I don't know why I'm just off for assignment, like addition, multiplication, subtraction, and division. So just do the same thing, right? I believe she would share that to you guys on the group. So I'm not going to share this code. So that means you're going to try to do it from your head or you rewatch the video, one of the two. It's just a way for you to like get familiar with all the whole wrapping I've been doing in this class. And yeah, in the next class we should talk about switch, for loops, and then wow, right? And yeah, I believe if we are done with these basic things, we should talk. I will try as much as possible to kind of like squeeze in classes into our next class, so that in the upper class, right, we can just up into introduction to Flutter. I believe some of you are already trying Flutter out, by the way. But if you're not, try to install Flutter. We're just going to like run briefly and maybe build a calculator application live and direct, and just see some features, right? How to use all this. I've been rapping. I've been talking about all these traffic lights. You might be looking at why. How is this useful in a real world, right? We are going to experiment that in a real world scenario. So we'll build a calculator application, and then we should be fine. So that's it from my hand. If anyone doesn't have a question, or does anyone have a question, let me just drop a question. Ask an open question. If no one has a question, right, I believe we should be fine.
Sorry, can you add streams and future to that next class where you have classes as reminder? You were going to talk about it, building this traffic like that thing, but you decided to go the normal way. So can you just add that so you talk about it next class?
Okay, yeah, okay, fine. Let's talk about streams, right? Yeah, let's talk about streams. It's going to be very very useful. Streams and futures. So futures and streams. So I don't forget futures, streams, and classes. Then we are going to talk about for loops. But do well to explore for loops on your own end, right? It's as simple as whatever you might want to think about. So we are going to explore for loops, but basically we are just going to be talking about advanced. This is basically advanced stats, right? So when you hear advanced stats, we are probably talking about features. We are talking about streams, and we're talking about maybe classes, abstractions, and the likes like that. But those are advanced OP and the likes like that. But we are going to explore. We are going to talk about all this in the next class. But yeah, thank you very much for hosting me. Do have a great day.
Thank you, Caesar. Ladies, does anyone have any question before we call it a night? I guess we all enjoyed the class today. Um, I guess no question then. Okay, Caesar, thank you very much. If there's any question, we would definitely reach out to you. All right, ladies, thank you for joining. See you next week. Good night.